This is the second FRQ on AP Final Week number 1. It's a chart problem. And anyway, they give you 3 different representations here. They give you data in a chart, they give you data in a graph, and they give you a function that is an equation. So we're going to see all parts of these things combining together here, which is kind of interesting. So anyway, let's go ahead and take a look at number 1. Number 1 says find the slope of the tangent to the graph of f at x equals pi. Okay, well, f, of course, is this equation right here, so you do have to kind of sort all that out. So it looks like I'm going to find the derivative here. So f prime of x, if we go over here and look at this, f prime of x is going to equal the derivative of cosine of 2x. So derivative of cosine is negative sine of 2x, and we have to multiply by the derivative of the inside function, plus e to the sine of x. E to the sine of x will be its own derivative, but we have to multiply by the derivative of the inside function, so we have a cosine of x there. And now we want to find the slope at x equals pi, so we're trying to find f prime of pi. So let's see, that'd be negative 2 sine of 2 pi. Sine of 2 pi is 0, so that's just going to be 0. And then e to the sine of pi, sine of pi is equal to 0. Times the cosine of pi, and let's see, e to the 0 is going to be 1, cosine of pi is going to be negative 1, so it looks like we get a final answer there of negative 1. Okay, let's go on to the second part of the problem. So part 2 defines the function k, and it's a composite function. It's h of f of x. Be really careful here. Make sure you notice that's not h times f, that's h of f. So function f is the input for function h. They asked me to find the derivative here of k, and again to evaluate it at pi. All right. So the derivative of the outside function, the derivative of h, is going to be h prime. Remember, when you take a derivative, the inside function never changes. So it's going to be h prime of f of x. But the chain rule says you have to multiply by the derivative of the inside function. That's f prime, okay? And then we're evaluating all this at pi. That's going to be h prime of f of pi times f prime of pi. Well, we already found f prime of pi back in the previous problem, so hopefully we were right, because that looks like it's going to be negative 1. Okay, f of pi. Let's go back here and look at this. If we go back to the original function there, function f is that right there. So if we put a pi into this, cosine of 2 pi would be 1. E to the sine of pi would be e to the 0, which is 1. 1 plus 1 is 2, I believe. So we're going to be taking, looks like h prime of 2, and then we're multiplying by negative 1. So let's go back to the chart. I think h might be the chart. Oh, no. H is the graph. H prime of 2. If you notice here, h prime of 2 is the slope at 2. The slope here, if you notice, is negative 1/3. It's a downhill sloping line. So it looks like we've got negative 1/3 times negative 1, which ends up equaling positive 1/3. And okay, I want to look at the grading sheet for this and make sure everything's good before we move on. I know you all can't do that, but for video, I probably should. Okay, so part A, that looks good. We get 2 points for that. And part B, we got 1/3. We're also looking good there. So we're already up to 4 points. So we're already up to a passing score. Not a great passing score, but a passing score. So anyway, it's all icing from here. Let's look at part C. Let m be the function defined by g of negative 2x times h of x. They want us to find m prime of 2. Okay, so this is a product rule problem. Of course, with the product rule, you take the derivative of the first term. That's going to be g prime. Inside function doesn't change, so g prime of negative 2x. Remember, you have to multiply by the derivative of the inside function. So I'm going to multiply by 2. Okay, derivative of the first times the second. The second was h of x. Okay, plus the first term was g of negative 2x, times the derivative of the second, and that's just going to be an h prime of x. There's no inside function to worry about there. And it wants me to find m prime of 2. Okay, so we're going to sub 2 in here. So that's going to be 2 g prime of negative 4 times h of 2 plus g of negative 4 times h prime of 2. Okay, let's just go find those values now. Those g values are on the table, in the table. G of negative 4, and be careful, that's actually g prime of negative 4. G prime of negative 4 is negative 1. So we've got 2 times negative 1. H of 2, if we look over here on the graph, the slope's 1/3, negative 1/3. So you're at negative 1/3 there, you're at negative 2/3 here. That's going to be h of 2. And again, that's h of 2, not... so here's what we've got currently. We've got 2 times g prime of negative 4 times h of 2 plus g of negative 4, h prime of 2. Let's go back up here. G of negative 4, looks like it's going to be 5 if you look at the table there. And times h prime of 2, that's the slope of h at 2. Slope of h at 2 is still negative 1/3. Okay, so let's put all this together. Let's see what we get here. That's going to be 2 times 2/3 in the end. We'll get 4/3 plus, it looks like it's going to be negative 5/3. Oh, that's nice. And looks like it's going to be negative 1/3. Let's check this one out. Let's see what's going on here. Did we get this right? Uh-oh, it's negative 3. Where is it negative 2 coming from? Oh, the derivative of the inside function here is negative 2. Oops, my bad. This happens, that's why you show your work. Negative, negative, negative. Okay, so that's going to be negative 4/3 minus 5/3, which is going to be negative 9/3, which is 3, okay? That's why they don't make you get 8 out of 9 in every question to get a 5, okay? You're going to make some mistakes. But if we go back here and look, I would have gotten a point for the derivative. Oh, actually, my derivative was wrong, too. Yeah, they lost a lot of points there. Anyway, I think I would have gotten 1 point there, but let's go on to the last part. Okay. Part D, is there a number in the closed interval such that g prime is equal to negative 4? And they want you to justify your answer. All right, so if you notice here, they're not asking about a function g. So this is not an intermediate value theorem problem. This is probably an average value or a mean value theorem problem, since they're asking about g prime. So let's think about that. All right. So the mean value theorem, the interval they give us is negative 5 to negative 3. So according to the mean value theorem, we could take g of negative 3 minus g of negative 5 all over negative 3 minus negative 5. We can find the average rate of change, okay? And that should be equal to the instantaneous rate of change at some point. So g of negative 3 here is 2. And g of negative 5 is 10. So we've got 2 minus 10 over 2, which is going to be negative 4. Is that what they gave us? Yes. Okay. So remember, by the mean value theorem, if your function is continuous and differentiable on the interval, and you really need to say that, but if your function is continuous and differentiable on the interval, then if the average rate of change is equal to a value, that should be equal to the instantaneous rate of change for some value of c in the interval from negative 5 to negative 3, okay? In your answer, you really need to say something about the function being continuous and differentiable. Notice up here in the original, they're talking about function g. They tell us that g is differentiable, okay? Differentiability implies continuity. So if they tell you it's differentiable, you can conclude that it's also continuous. But you do need to say that, okay? So let's look at the answer key here. Well, notice they say g is differentiable. That implies it's also continuous on the interval between negative 5 and negative 3. They found the average rate of change, and then that's got to be equal to the instantaneous rate of change somewhere. So therefore, by the mean value theorem, there's at least one value c in the open interval, not including the endpoints, such that g prime is equal to negative 4. So write it up nicely at the end to make sure you get that last justification point. And that's it.